You are listening to the Big Blue Marble Podcast with Anwar Knight.
The Greenland ice sheet has lost 160 billion tonnes of ice through surface melting alone.
The Greenland ice sheet covers 80% of the island. If all of it melted, it would raise sea levels by 7 meters.
As the planet gets warmer, the Arctic is heating up at double the rate, and Greenland in particular is warming even faster.
Those are just a few clips of media reports, headlines from around the world tracking the incredible melt that occurred in Greenland this summer. The video and pictures were so compelling, and perhaps in part because we aren't very familiar with this region. But we should be. Because what happens in Greenland does not stay in Greenland. If this melting trend continues, it will affect people everywhere. Greenland is the world's biggest island by area that is not a continent, and the least densely populated territory on the planet. Almost 80% of the landmass is covered by ice, and we're not talking just a topcoat. This is over 2 kilometers thick, and it's here, along with the Antarctic ice sheets, where you will find 99% of the freshwater ice on Earth. That's astounding. Again, 99% of the freshwater ice on Earth. And in an instant, that's me snapping my fingers, 12 billion tons of ice vanished in just 24 hours because of an Arctic heat wave. Researchers say that melting occurred on more than 90% of the ice surface, and it's not the first time. The region's ice sheet are now melting 6 times faster than it was 40 years ago. So are we destined for high sea levels, altered weather patterns, and more damaging hurricanes? Just a few of the disastrous impacts linked to the melting of Greenland. Martin Stendal is my guest today. He's been studying the changes closely. He's a climate scientist from the Danish Meteorological Institute in Copenhagen, Denmark. Plus, also coming up, we'll update the Blue Files, where we discover details on a new type of concrete pavement that could help cool down cities. It's all straight ahead. I'm Anwar Knight, your host, and this is the Big Blue Marble Podcast.
Have a question, comment, or show idea? Let us know at bigbluemarble.earth.
Well, good day, Martin. We really appreciate you joining us.
Good day, Anwar.
You know, the sheer numbers to quantify this event are staggering, and we mentioned some of that at the top of our show, but you tweeted, enough water melted in 2 days to cover the entire state of Florida in 5 inches or 13 centimeters of water. So let me ask you, Martin, is this as catastrophic as it appears to be?
Well, it depends how you look at it. One has to take 2 things into account. The amount of ice that melted away, and looking at this comparison to Florida, that is quite a big amount of water or of ice. But actually, it's only a very tiny amount of the entire ice sheet. So this event isolated doesn't make the big change. But that's, of course, only half of the picture. If you look at how often this happens and how strong these events are, then actually we get a story out of that. And we have had several melt events during the last couple of years. The last big one was in 2012, and then this one in 2019. And if you look at the contribution that Greenland makes to sea level rise, because that's where all the ice ultimately ends, of course, the sea level has risen by approximately 1 centimeter over the last approximately 15 years, only by ice melting from the Greenland ice sheet. This does not include that the water gets warmer and therefore takes up more place. It's just the amount of ice that melted down from the ice sheet during these 15 years.
You bring up, 7 years ago, July 2012. I know scientists have been monitoring the ice sheet extensively since back in the 1950s, and that's when they first started tracking some of the melting. So some ice loss is routinely expected. But how do we compare these two, from the massive melt that happened in July 2012 versus this one that just occurred? Is this bigger? Is this a much more widespread event in contrast to the one that occurred 7 years ago?
It appears that 2012 was a little bit larger, but the thawing season, that's why I mentioned that, isn't yet over. But it looks probable that this one is second only to 2012.
What surprised you the most as a climate scientist when this melt occurred?
the sheer size of the event. So within a couple of days, as we said at the beginning, several gigatons or cubic kilometers of ice just disappeared into the sea. And we have observed thawing right way up on the ice sheet. The highest point in Greenland, the temperature was close to 0 degrees. That is interesting because summit is at 3,220 meters above sea level, and it's surrounded literally by hundreds of kilometers of ice and 2 miles of ice below it. So temperature is very close to zero and thawing, or nearly thawing up there. That's quite unusual. So it was unusual for me in particular to see that this heat wave in Europe kind of continued to Greenland. Actually, it was also interesting to see that we could forecast that quite well a week in advance. Events like these don't happen that often. And while you cannot really put climate change as responsible for an individual event, if you look at several events in a row, then of course a story evolves from that.
So you're saying, I want to just backtrack a little bit, the fact that we had temperatures hovering near the freezing mark at such a high elevation, that would be very rare, correct?
Yes, indeed.
And when it's happening to such an extreme, this would be, though, yet another indicator of the growing trend. So it's not just the one blip, because as I understand it, when you look at these ice sheets or even you look at the Arctic sea ice, there is a cycle. There has been some data to suggest that, maybe 200, 250 years cycle, there may be that one major event, you get a warming, and then it starts to calm back down. But now we're starting to see, 2012, that was another major one. So it's less than a 10-year difference. Is that alarming in itself?
In a way, it is, yes. I mean, one has to take into account that the Arctic and Greenland in particular warms up at least twice as fast as the globe as a whole. So if you look at a station like Nuuk, for example, which was well below zero only a couple of maybe 10, 15 years ago, and they now have an average temperature which is well above zero, that's of course something where we can see the difference directly. And with a huge increase of temperature over the last decades over Greenland, we have had heat waves all the time, of course, but heat waves today are warmer than heat waves 20 or 30 or 100 years ago. So that makes some kind of concern, yes.
And the heat waves of today, I mean, we're talking extreme heat wave. This isn't just a warm-up in Greenland standards. I mean, this is way off the charts.
Yeah, it was almost a new record. Only one particular day in 2012 was warmer. But if you look at another thing, that is the area on the ice sheet where we actually observe melt, then we had something on the order of more than 60%. And just imagine, Greenland as such is very high. There are the coastal areas, we have melt all the time in summer, every year. But if you go up on the ice sheet, then actually this becomes a quite rare event because the temperature increases in the subtropics as it does. And if the temperature increases in the Arctic as it does, and the temperature in the Arctic increases much more than in the subtropics, then of course the temperature difference will become smaller. And there is reason to believe, I say it a little bit carefully because that is ongoing research and many people are researching on that right now. There's reason to believe that this slows down the jet stream, so it can't move as fast. And if that happens, there's also reason to believe that it gets meandering more and more. And if that's the case, this is a point where we can get so-called blocking situations. The blocking would mean that the normal flow from west to east is interrupted, and it's in the right position, right over Greenland. Then we have quite a large amount of warm air there. And these blockings have the property that they are really stable and can stay on a area on the order of a week maybe. And that would of course mean, coming back to the thawing, that we might expect a trend which is much stronger than the linear trend we normally assume.
And just for our listeners, when we talk about the jet stream, this is like a river of air that is sitting 25, 30,000 feet from the ground. Airplanes sometimes piggyback on that to accelerate the journey. And that's what carries our weather systems. An area of low pressure will get piggybacked on that storm, on that track, I should say. Is it fair to assume that if this were to happen, when you say a blocking pattern, that some of the storms, even in North America per se, they could slow down, they could be more stationary and have impacts in North America too. Would that stand to reason?
Not exactly, but almost. It would not be individual storms, but rather, now let's say, stormy situations. So the individual storms probably would do the same as they always did, but the overall tendency that another storm forms and does the same thing, and maybe a third one also doing the same thing, this probability would increase. But it's also possible, of course, if we are lying under the high pressure part of such blocking, that we would have extended periods of dry weather or even drought. And actually, we had such a weather situation, which is very unusual for Europe. We had that in last summer, between April and August, which was extremely unusual. And we had very little rain here in Europe. And that would, of course, be the other side.
And, there are various measurements and data that is routinely recorded and calculated. Some of those details are coordinated by you and posted online for the public to see. And it's really fascinating stuff. And they can access that at www.polarportal.dk. That's polarportal.dk. So it's an updated monitoring of the Greenland ice sheet as well as the Arctic sea ice. And I wanted to know if you could give us an example of the research that's posted there.
What we do is we are using observations to enhance a weather forecast model with which we make these forecasts. Then, of course, we try to check that with observations portal. It's direct observations on the ground. It's observations from satellite, and it's model-based data plus observations.
And I suspect in the years to come, it will be a crucial player on getting and informing people on real-time data on what's happening in this part of the world.
Yeah, I think so. We strive at having the data updated once per day. So that means you will normally always be able to see data from yesterday. And there are not so many institutions around who do that. So if your listeners are interested in, let's say almost up-to-date data, then the Polar Portal would be an interesting address. I should maybe also say that we have it in Danish and in English. And
yes, I noticed that. You can link it for English, and that's what I was looking at. I was fascinated by it.
Okay, thank you.
Yes. Now, you mentioned about the heat wave in Europe. That was essentially the catalyst of this big melt. It was an unprecedented heat wave that smothered many parts of Europe. Dozens of records were broken. Major cities experiencing the highest temperatures in the recorded history. Paris had 42 degrees Celsius or 109 Fahrenheit. And Greenland is normally an Arctic climate. So temperatures, as you mentioned, soared. But what's interesting is the effects of that warm-up linger, and I think this is a really important aspect. The heat is amplified here. It's very intense, and it's directly related to the combination of the warm temperatures and the melting snow. And I wonder if you could explain that a little bit more detail.
Yeah, that is totally correct. I mean, if we have temperatures of 40 degrees in Europe, it's warm and then it gets cooler again. But actually, if you look at Greenland, and we have temperatures which normally should be right below zero, but they are right above zero, then of course we start something which reinforces itself. They are white, of course, so incoming solar radiation, most of that will be reflected back to space. But if they melt, normally you can see the much darker bedrock or the sea, ocean water, which is also quite dark. And if that happens, a large part will no longer be reflected, but actually it will be absorbed by the underground. And by doing that, the underground warms, of course, and by that we can get even more melting and so on.
Because that process is already underway, so it's easier to amplify and to keep it going, right?
Yeah, that's the main process that is responsible for that. Yeah, that's right.
Much of the world was in awe when they saw the images or video that seemingly never-ending torrent of ice water that was gushing and flowing and carving its own path. In my recent memory, I don't think I've seen anything ever like it, but the focus by and large was on the actual melt. And what I find interesting is the other side of this, and that is that the ice water, the glacial melt, has to go somewhere. We got caught up in the melting, But we have to remember that eventually this all has to make its way somewhere, and that's to the Atlantic Ocean. So I want to ask you, Martin, what are the consequences of 197 billion tons of ice melting so quickly? And I use that number. Scientists are suggesting, you would know this, that is the amount for the entire month of July that melted. What are the consequences?
Yes, the consequences are, of course, that this large amount of meltwater contributes to sea level rise. And while the sea level rise due to this particular event may not be that large, it sums up over time. As I said, all these melting events, larger ones like 2012 and 19, and smaller ones, have already summed up to more than a centimeter just in the last 15 years. Then also we have, of course, the thermal expansion of water, which adds to that. So we actually at well more than 1 centimeter. I should also say, if all of the Greenland ice sheet melted, something which will not happen within the next couple of thousand years, but if it did, it would mean that the sea level would increase by something on the order of 6 or 7 meters. So that's the direct effect that we get a sea level rise. Then people have been concerned, the water running into the Atlantic Ocean ultimately, that is fresh water. Cold water is heavier than warm water, but salty water is also heavier than non-salty water or fresh water. So the idea was that if we add large amounts of fresh water, we might slow down the thermohaline circulation. And that would, of course, be a major effect.
That was a lot of material to ingest here, so I just want to make sure I have it right. When we talk about the circulation of the waters in the ocean, the fact that we have this push of fresh water going into the ocean, mixing with the salt water, so it will change the balance of the regulatory circulating patterns?
Yes.
And ultimately, what would that do? What would be the cause and effect of that if it was pronounced?
Yeah, there's only one region in the world where we have a downwelling of this water, and that can only happen if the water is heavy enough. So it needs to be cold enough and it needs to be salty enough. Now, the decisive point here is the salt. The water wells down in the northeast Atlantic near Greenland and near Iceland. So the thought is, if we add large amounts, really large amounts of fresh water into the Atlantic Ocean, for example, by melting from the ice sheet, there would be a lot of fresh water added to the surface waters there, which then mix with the salty water so that the resulting water mass is less salty than it should be. And if it's not salty enough, that would mean that the circulation, the downwelling part of the circulation would weaken, and that would, of course, then further on weaken the whole circulation. It does not look like this is something which will happen within the next couple of centuries, but since some models say it and some models don't, we cannot rule it out.
And I'm just curious, I would imagine that would have an impact on ecosystems too, right?
Oh, yes. I mean, if that really happened, if it happened, then in Europe we would have temperatures like you have it in Canada, so much, much colder than we are used to here. If you look in, I don't know, Quebec or Ontario, for example, the ecosystems are totally different from what we have here in Germany or Denmark, say. So if that happened, then it would, in Europe, it would be, at least in Northern Europe, it would be considerably colder than we have it now, because the warming part, the Gulf Stream, would get weaker or maybe even stop.
What about hurricanes? Could rising sea levels fuel stronger hurricanes for the U.S. and Canada's East Coast? Water's the big killer in a hurricane. The drowning, the fact that the water moves inland where people live. If the levels are already rising, is it probable that it could be more intense, the hurricanes?
I think we have to separate two things here. One thing is, first we need to get a hurricane. And in order to have that, first of all, we need high temperatures. The ocean water must be warmer than 26.5 degrees. Right. Now, with the ongoing global warming, we get larger and larger areas where we pass this threshold. So hurricanes can form over areas where we did not know that. But then the other thing is, of course, if we have a sea level rise, we could imagine that lower lying parts, maybe of Florida, would be inundated. But even if that is not the case, or if we would build dikes, then of course the potential damage is much larger if the water stands 1 meter higher than it otherwise would be. Then at the 4 or 5 meters, the hurricane contributes to that. Then it's clear if you are somewhere inland, it makes a difference if the water goes up 3 or 4 meters. So indirectly, that means in terms of damage, the sea level rise, of course, has an effect, but not for the formation of hurricanes.
Right. Do you think this is going to be a record-breaking year for ice loss in Greenland?
Probably just not, but we will. I'm convinced that we will.
Let me clarify that. So was that a yes or a no?
That was a no. I am pretty confident that we end on a second rank, just behind 2012. But it will be quite a close race. It doesn't look as if we get more thawing than in 2012. I should also add that we have very little sea ice at the moment. We didn't talk about that. So the sea ice in the surrounding of Greenland or the Arctic seas is also at a near record low level. And here, I think it's too close to call. We may end up very close to the last sea ice minimum. Whether on this or the other side, I simply cannot say, because there's another 4 weeks until we get the sea ice minimum.
And is there any chance with the return of the winter season that this ice loss could be replenished? I'm looking for a glimmer of hope here.
Well, of course, we have growing snow and ice over the winter period, so the thawing thing will stop. Overall, the Greenland ice sheet is losing ice, full stop. Then, on the other hand, of course, we have an effect which goes into the other direction, and that is if it gets warmer, warm air can bear more water vapor than cold air. So if it gets warmer, then we will get more precipitation. In Greenland, that would, of course, normally be snow. But just to mention it, we have had situations on Svalbard, that's 80 degrees north, very close to the North Pole, where there was rain, not snow, rain in winter. So that's not a guarantee. On Greenland, of course, if you go up to 1,000 meters height or something like that, we will definitely have snow. So part of what has been melting away can be replaced by increased precipitation. But overall, this is not enough to replenish what has been lost through these melting processes.
You know, more than 192 countries have signed the UN's Kyoto Protocol to reduce the industrial emission of carbon dioxide in the hopes that we can slow down global warming. And there is the reality that it would take very long to reverse it, but something has to be done, something proactive. But you're the expert, Martin. Can we reverse this, or at the very least slow it down?
Well, whether we can reverse it, I don't really know. We can, of course, slow it down. The only way to either slow it down or reverse it is if the temperatures are lower than they are today. With the ongoing temperature increase, we cannot manage it. So the thing we need to do is we have to stop firing fossil fuels into the atmosphere. And the faster we do that, the better it will be. But even if we do it later, it's better than not doing anything at all. Unfortunately, that is exactly what things look like in the moment. So people stare at what is going on, and many people say, "Oh, we should do something," but not so much has happened.
And the thing is too, I think part of the problem is this is not a quick fix. We have to realize that if we reduce the flow of greenhouse gases into the atmosphere, that's one thing. But the other thing is we have to learn to adapt to a new way of life globally, because this won't, the changes wouldn't happen in 4 months, 6 months, 5 years. It will take a long time. So we have to live in this new reality while trying to make a concerted effort, correct?
Yeah, definitely. And if you look at the case of Greenland, the changes I have been talking about, they act on a timescale of, let's say, hundreds, if not thousands of years. So if you want to avoid that the whole ice sheet is melting down in, 3,000 or 5,000 years from now, we will have to act now. Because if we don't stop it, then it goes on. And with the increasing warming, we will get larger and larger areas which are prone to melting and larger melt events. And the whole thing is just reinforcing itself. So we have to do something now.
Can we say that we are still not at the point of no return?
I hope so, yes.
Martin, I want to thank you for this. I know you have a passion to share science to the public, and we appreciate you doing that with us today. Dr. Martin Stendal, climate scientist at the Danish Meteorological Institute, joining us from Copenhagen in Denmark. Time to travel the world as we open this episode's edition of The Blue Files. I'm sure you've planted a tree, but how about 300 million of them? Listen to this. The campaign was named Green Legacy, and the entire country of Ethiopia took it to heart. The African nation collectively planted more than 353 million trees in just 12 hours, which officials believe is a world record. As the term legacy implies, the effect is long-lasting. Reforestation initiatives continue through the rainy season as Ethiopia works to plant 4 billion trees between the months of May and October. The country is relying on the continued efforts of millions of its citizens to build on the momentum already underway. This particular planting breaks India's previous record set back in 2017 when they planted 66 million trees in 12 hours. A team of engineers at Rutgers University have developed a permeable concrete pavement that they say can help cool cities. In large cities, the average air temperature can be from 2 to more than 5 degrees higher than in less densely populated areas due to what's called the heat island effect. This happens when pavement and buildings capture and retain the heat during the day and continue to warm the area after the sun goes down at night. Of course, the impact is the need for more energy for air conditioning, increased air pollution, and greenhouse gas emissions, not to mention the danger of heat stress to the community at large. This new permeable pavement contains large connected pores, allowing water to drain through and reduce the pavement's temperature. Water in pores will also evaporate, reducing pavement surface temperature. The material also does a better job of reflecting heat than black asphalt pavement. And now we head to India, which is now home to nearly 3,000 tigers, which is a third more than it had 4 years ago, according to government officials. This preservation effort makes the country now one of the biggest and most secure habitats for the endangered animal in the world. This is a major conservation success story following a devastating history of decline for the animal. For decades prior to 1925, it was estimated that 80,000 tigers were killed in India, with only 1,400 remaining in 2004. These beautiful animals are the largest wild cats in the world. Adults can weigh over 600 pounds and travel up to 65 kilometers an hour. India is now home to 70% of the world's tigers. And that's this edition of The Blue Files. Wow, look at that. Another episode coming to a close. I want to thank you for your time today. Be sure to subscribe to the Big Blue Marble newsletter to get show updates, behind-the-scenes access, and other great stuff, including some prizes. I'm going to be launching that in the coming weeks. BigBlueMarble.earth is the website. Of course, that's where you can also subscribe to this podcast as well, so you will never miss a show. I'm also on Twitter and Instagram, @AnwarKnight, if it's easier to connect that way. But most importantly, my friends, I ask you to please share this podcast. Let's propel the change that needs to happen to save our planet. I'm Anwar Knight, wishing you a great day on the Big Blue Marble.
That was another great show, Daddy.